Okay, on number 1, on page 2 of this review, we have 4x minus 8 equals 10x plus 34. So the first thing that I see is that we have x's on both sides of the equation. And so I'm going to take away the x's from one side. I'm going to do minus 4x. So that'll cancel out with the positive 4x we already had, give me negative 8 equals 6x plus 34. Then we're going to subtract 34 on both sides. Subtract 34. And that's going to give me negative 42 equals 6x. I would then divide by 6 on both sides. And that's going to give me x equals negative 7. On number 2, we have the set of parentheses, so we're going to distribute 5 to the 1 and 5 to the x, giving me 5 times 1 is 5, 5 times x is 5x, equals 5x plus 5. We once again have x's on both sides, so I'm going to subtract 5x to cancel out. What I find is that on both sides I have 5x minus 5x, so they will both cancel out, and that leaves me 5 equals 5. This is a true statement, which means that it is infinite solutions. Okay, number 3. We have negative 6x plus 23 plus 2x equals 15. We have like terms to combine. Negative 6x and 2x are on the same side of the equation, so we're just going to combine them. Negative 6x plus 2x is negative 4x. Bringing down the rest, I have plus 23 equals 15. Then I would subtract 23 from both sides, which would give me, they would cancel out on the left side, giving me negative 4x. And 15 minus 23 is negative 8. I would then divide by negative 4. And I would get x equals 2. For number 4, this is an absolute value equation, so it looks a little bit different than the other ones we've looked at so far because it has these two absolute value symbols on the other side. When we have that, we need to first make sure the absolute value is by itself, so there's nothing else on the same side of the equation, and then we're going to set up two equations equal to the positive and negative version of the other side. So first I'm going to do x plus 6 equals positive 3, and then I'm going to do x plus 6 equals negative 3. So for this equation, it's pretty simple to solve. We're just going to subtract 6 from both sides for both of these equations. Over here, the plus 6 and minus 6 will cancel out, and 3 minus 6 is negative 3. Over here, the plus 6 minus 6 cancels out, and negative 3 minus 6 is negative 9. So my two solutions are negative 3 and negative 9. For number 5, it's a little more complicated because the absolute value is not already isolated. It's not already by itself. We first have to add 14 to both sides to get rid of this negative 14 over here. So that will cancel out, and that will give me the absolute value of 4x minus 3 equals 13. Now the absolute value is by itself, so I can do the two equations. 4x minus 3 equals positive 13, and 4x minus 3 equals negative 13. For both of these equations, I'm going to start by adding 3, which on the left is going to give me 4x equals 16. On the right, it's going to give me 4x equals negative 10. I'm going to have to rewrite these at the top so I have more space. So I have 4x equals 16 and 4x equals negative 10. For both, I'm going to divide by 4. On the right, I'm going to get x equals 4. On the left, I'm going to get x equals negative 5 halves. Or as a decimal for this one, it would be negative 2.5. For number 6, it looks like it's simple, already ready to go. We have the absolute value by itself. However, the absolute value is equal to a negative number in this case. But you cannot have an absolute value that's equal to a negative number because it tells you the distance from 0. Distance is always positive. So number 6 actually has no solution. because it's not possible for an absolute value to have a negative number. For the next section, we're looking at inequalities, which are similar to solving equations. It just says that things are not equal, so one side is going to be bigger than the other. So we have x minus 6 is less than 8. Just like solving an equation, I'm going to add 6 to both sides, which will cancel out with the minus 6, and I'm going to get x is less than 14. 14 will go on my number line, so I'm going to have 14, 15, 16 going to the right, and 13, 12 to the left. Here's my number line. And because x has to be less than 14, I'm going to have an open circle, and the arrow going to the left. For number 2, we have x plus 5/3 is greater than or equal to 46/6. First thing we're going to do is we're going to subtract 5/3 from both sides. We can subtract 5/3 from both sides. We'll cancel out here, and that will give me x is greater than or equal to, let's see, 5/3 would be 10/6, so that would be 6. As a side note, if you are curious, 5/3 is 10/6, so it would be 46/6 minus 10/6, which would be 36/6, and that gives me 6. So for number 2, we have x is greater than or equal to 6. 6 will go on the number line, in the middle. We have that x is greater than or equal to 6. So we're going to have that filled in circle, and then the arrow going to the right, because it's greater than. For number 3, we have negative 25 is less than negative 5x. Here we would need to divide by negative 5. And I'm going to get a positive 5 over here. Negative 25 divided by negative 5 is a positive 5. On the right side, it'll cancel out and give me x. But remember, when we divide by a negative number, we need to flip the symbol. So I'm going to have 5 is greater than x. But I actually prefer to have my x on the left side. So instead of saying 5 is greater than x, I'm going to switch it around and say x is less than 5. These are two ways of saying the same thing, so neither one of those would be wrong, but I just prefer this one because it makes it easier to graph in the number line. So if I have x is less than 5, I'm going to put 5 on the number line. Because x is less than 5, I should have an open circle at 5, and it should be going to the left. Okay, the other two problems are somewhat written out step by step in the answer key that's already posted on Canvas, so I'm not going to go through these on these videos. So if you have any questions, let me know, and good luck.